All right, in this lesson, we're going to take a look at solving right triangles. We know how to find missing sides using some trigonometry, but how can we find missing angles? That's the question we want to know now. So if we have a right triangle, for example, and if I tell you this is 2 and 5, how do we find this angle right here? What is this guy? Is it 20 degrees, 30 degrees? What is it? Well, that's what we're going to find out in this lesson. So to start off, let's take a look at some triangles here. And we want to figure out which ones of these angles have a cosine of 0.5, all right? So we want to know the cosine of some angle is equal to 0.5. Well, 0.5 is the same as a half, right? And so we want to know what goes in this little box, which angle in this triangle. Well, when we think about our cosine, we can remember our SOHCAHTOA, SOHCAHTOA. Just a good way to remember which one is which. And so we know cosine is the adjacent over the hypotenuse. So we're saying that this is our adjacent number. It's adjacent to some angle, and this is the hypotenuse. Well, yes, indeed, our hypotenuse is 2. So which angle has the adjacent of 1? Well, that would be this guy. This side is 1, and what is it adjacent to? Is it adjacent to A? No, it's not adjacent to A. Is it adjacent to B? Yes, it is, all right? So the angle that we're looking for is B. So what we just did is, knowing the cosine, we found the angle by looking at the triangle, all right? We're kind of going backwards. Now, instead of finding the ratio, we're finding the angle, all right? So here we got another one down here. We want to determine which of these two angles has a tangent of 0.75. All right, well, we know tangent of some angle, back up, tangent of some angle, I'm going to use a generic A for right now, is opposite over adjacent, okay? That comes from the TOA, part of our SOHCAHTOA, okay? So we're saying the tangent of some angle, we don't know which one it is equal to 0.75. Do you know what 0.75 is as a fraction? Well, 0.75 is 3/4, right? So 3/4 is what we're looking for. So we want to know which angle has 3 as an opposite or 4 as an adjacent, and 4, I should say. Okay? Well, here's our 3, here's our 4. So is 3 opposite to Q? Nope, it's not. It is opposite to R, though, right? So we see that 3 is opposite to R, 4 is opposite adjacent to R. So R is the lucky winner. Okay, so angle R is the angle we're looking for. Now, we could have also done this. We could have just gone tangent of Q is opposite over adjacent. And if you plug that in your calculator, it's 1.3 repeating. Okay, tangent of R is 3/4, which is 0.75. So R is our angle. All right, so either way. So let's pause here. Go ahead and pause the video. Go to your assignment and try problems 1 through 3 on the assignment. Then, once you're good with 1 through 3, come back to the video and we'll go to the next part. Pause and go to 1 through. So what we just did is we were given the ratio and we found the angle. So we're kind of going in reverse here, and we have a name for this. We call this the inverse trigonometric ratios. So the inverse trig ratios go in reverse, you can think of it, all right? So we have, if we know the ratio, if we know the tangent of A is something, if we're given that, then we can use the inverse tangent, and the inverse tangent of that ratio is the measure of angle A. Okay, so if you want to find the angle, we can use the inverse tangent, all right? If we know that this is 2/5, then we're going to find the angle by saying the inverse tangent of 2/5 is the measure of that angle A. Okay, 2/5, opposite over adjacent. That's how we define tangent. So that will give us the angle, all right? Inverse sine. If we know that the sine of A is some value y, well, the inverse sine of y is angle A. And similar idea for cosine. The key here is this, that the inverse functions find angle measures. That's the key, okay? So if you want to find an angle measure, use the inverse sine or inverse cosine or inverse tangent, all right? So inverse functions find angle measures. Keep that in mind. So here we have three angles, not necessarily in the same triangle, just three acute angles, and we want to find the angle measure. Now, so here we're told the tangent of some mystery angle is equal to 0.75. Well, what we're going to do is we're going to rewrite this. We're going to go in reverse. We're going to kind of undo this by saying A is the inverse tangent of 0.75. We write inverse tangent with this -1 exponent, but it's not really an exponent. It's just a notation thing. So we can go to our calculator, and we actually have an inverse tangent button. So to find this inverse tangent, we're going to take our calculator, hit the shift key. That'll change this tangent key to a tan -1, an inverse tangent. And then we want to hit inverse shift, tangent, and type 0.75, and that'll give you this angle 36.9. Okay, we'll round off to 36.9. Okay. So we know the angle that gives us a tangent of 0.75, that opposite over adjacent. All right, so why don't you pause the video here. It's a good place to pause. Go see if you can find the angle that gives you a sine of 0.87 and a cosine of 0.15. All right, so two different angles there. So remember, we're going to find the inverse sine of 0.87. Okay, so go to pause the video. Go see if you can find those out. Hopefully you found that B is about 60.5 degrees. And then C, to find the inverse cosine of 0.15, we plug that into our calculator, and we get about an 81.4 degrees. So if you have an 81.4 degree angle, you will have a cosine of 0.15, all right? So now if we have a triangle like this, we can find the measure of all the angles, okay? How can we do that? Well, if we take a look here, we've got 20 and 21. Those are legs. Now let's look for angle E. 20 is the opposite. So we know the tangent of E is opposite over adjacent. And so we don't know how big E is, but we do know the opposite. That's this guy over here. We do know the adjacent. That's 21. So just like we did up here, if we know the tangent, then we can do the inverse tangent. The angle is the inverse tangent of the ratio, 20 over 21. And we go to our calculator and just type that in and see what we get. So on our calculator, if we type shift and inverse tangent of 20 divided by 21, just to type the fraction in there, we get 43.6 degrees. So that's a 43.6 degree angle. So this guy right here is 43.6 degrees, okay? So how about, let's get these guys out of here, okay? How about the other one? Well, we want the inverse tangent, tangent first of all. We always start with a true trig equation. In this case, we want to use tangent because we don't know the hypotenuse, so we don't care to know it. D now is the inverse tangent of 21 over 20. And following the same step, second inverse tangent of 21 over 20, we get about 46.4 degrees. And that's good because these two angles add up to 90, and that has to be true in a right triangle. All right, why don't you pause the video now and go do practice problems 4 through 6 on your practice assignment. Give it a try, and then come on back, and we got a little bit more we'll do here. So how'd those problems go for you? 4 through 6? Were you able to find those inverse tangents and sines and cosines and all that stuff? Hopefully. Okay, so now our big idea here that we want to do, so we get our calculators out of here. Okay, so we want to solve some right triangles. So to solve a right triangle, when we say solve the right triangle, that means we want to find everything out about it. And we can solve a right triangle if we know two sides, or we know an angle and a side. If we know two of anything, well, that's not true. We got to know at least one side. But if we know two parts, either two side lengths or one side length and one angle, we can find everything out about the triangle. All right? So let's do that. So here we've got two sides. We want to find the third side. Okay? And so we can do that with Pythagorean theorem. We've done that a lot. 2 squared plus 3 squared equals c squared. So we've got 4 and 9. We've got 13 square root. And we get c is the square root of 13. Done that a whole bunch. Okay? So c is the square root of 13. Now directions say we want to find it to the nearest tenth. So let's go ahead and round that off. Punching that in the calculator, we get about 3.6. Now, we're going to use square root of 13, even though 3.6 is the approximate answer. Now, let's make some equations. Well, we want to find b. So let's pick some sides. Doesn't matter which one. Let's pick 2. Let's pick the 2 and the square root of 13. And we're going to use it as a square root of 13. 2 in relation to angle b is the opposite, right? 13 is the hypotenuse. Which ratio uses opposite and hypotenuse? Well, that is sine. Sine of b is opposite over hypotenuse. So we use the opposite, which is 2, the hypotenuse, and we fill in our equation there. We don't know what b is. How do we find the angle if we know the ratio? We use the inverse sine. That's what we just did in the last couple problems. We're going to go backwards, and we want to know what is the inverse sine of the 2 divided by the square root of 3. Go to your calculator, try it out, see what you get. Found a mistake here. If you I type that in, it will say error. So wrote something wrong. Did you catch that? It's 13, not 3. So it's 2 divided by the square root of 13. Let's try that. So 2 divided by the square root of 13. Punch it in my handy-dandy calculator. We get 33. B is about 33.7 degrees. Okay? Let's go ahead and find A. Now, A has 2 as an adjacent, so it's now the adjacent to A. And 13 is the hypotenuse. Well, which ratio is adjacent over hypotenuse? SOHCAHTOA. All right? So it's cosine of A is adjacent over hypotenuse, 2 over the square root of 13. We want to find the angle, so we use the inverse cosine. So the inverse cosine of 2 over the square root of 13. Let's see what we get. Punch it in the calculator. We get A is approximately 56.3 degrees. There you have it. Okay. All right, so we found our missing side, 3.6, and our missing angles. Once again, use that square root of 13. Don't use this 3.6. You'll get an answer that's a little off. Use the square root of 13. It's better there. All right, so we can now find all the sides, all the angles of our triangle if we know 2 parts. That's called solving the triangle. So last example here, what if we know an angle and a side? Well, we can find this angle easily because we know these two add up to 90. because all three angles add up to 180. So the measure of angle G is just going to be 90 minus 25, which is 65. So we now know that this is 65 degrees. And so now we can find these missing sides like we did in the last couple lessons. All right? So we've got 65 degrees for G. Okay? And now let's find H. Well, H is, what do you want to call it? Maybe adjacent to G? Sure. Okay, let's call it adjacent to G. So we've got adjacent using SOHCAHTOA. Okay. Cosine of angle G is adjacent over hypotenuse. So cosine of our 65-degree angle is h over the hypotenuse. We can multiply both sides by 13 here. And we get h is equal to 13 times the cosine of 65. And that comes out to be 5.5. Okay, so we got h. Let's find g real quickly. Well, how does g relate to that angle h? G is the opposite. You could use, oh, I'm sorry, it's opposite to G. Did I say that right? Big G and little g. Little g is opposite to angle G. Okay? So we can say the sine, opposite and hypotenuse is sine. So let's use the sine. Sine of angle G is little g over the hypotenuse, 13. But let's write that right. Let's write it as adjacent over the hypotenuse. So sine of G, which we know, 65, is G over 13. Let's finish it off by multiplying by 13, because we want to get rid of that. And 13 times the sine of 65 gives us 11.8. So G is 11.8, and we are done. All right, so just by knowing two parts, we can find the whole thing. That's how it works. You can solve the triangles. You are now triangle masters. So go back to your assignment and work on the rest of it. Good luck.